me. हम कह रहे थे बेंजीन हमने स्टार्ट किया था and I had started talking about अच्छा we had started talking about the structure of benzene कि जिसके अंदर there's a carbon atom and that carbon atom is bonded to 3 atoms. जिसका मतलब है it's sp2 hybridized which means कि carbon has total 4 electrons. 3 get bonded with other atoms. They get pulled by other atoms, and one of the electron is remains unchanged. So what would happen in that is that each carbon atom in benzene is identical. It's bonded to 3 atoms, and the fourth electron, this one, the blue one over here, that अच्छा this blue one over here, उसको मैं darker shade भी कर देता हूँ. So this one over here, it अच्छा it remains it ends up forming a pi bond with other p orbitals that are neighboring it, and all of them are identical. And one very important thing about this that we discussed yesterday was that alkenes also have pretty much the same thing, the same arrangement. That a carbon is sp2 hybridized, and there's a p orbital that is involved in pi bonding with the other p orbital from another carbon atom. Except for the fact that there was one major difference, and that was the major difference was that the pi electron cloud in benzene has a lower charge density. The reason it has a lower charge density is because the electron in the p orbital, not only is it overlapping with the atom to the left, but it's also overlapping with the atom to the right. जबकि in comparison, in alkenes, the electron cloud is very localized because the orbital is only bonding to the carbon atom to the left. That's it. So the electrons are pretty much somewhere in this middle region, and they're very concentrated. So the charge is a lot more distributed in a benzene ring, whereas in an alkene the charge is a lot more concentrated. So both have pi electron clouds, uh, but benzene's pi electron cloud has a lower charge density, which means that it's not going to attract uh, electrophiles, attract or repel. It would have weaker polarizing power. Okay, this one is going to have weaker polarizing power. जबकि जो दूसरा है, the other one, this one over here, alkenes have stronger polarizing power. ठीक है, clear है? सारा is clear? अबुरेरा clear है?
Yes.
Yes, sir.
So the next thing is mechanism. Both of them have electrophilic reactions. ठीक है, because electrophiles, they get attracted to two electrons. But in benzene, you have electrophilic substitution. Whereas alkenes, which we discussed earlier, they also have electrons. Anything that's attracted to electrons is an electrophile, and they have electrophilic addition reactions. ठीक है, so the mechanism is going to be different, mainly because of this charge density. ठीक है, the charge densities are different. So let's start with electrophilic substitution reaction of benzene. So electrophilic substitution in benzene. Now what happens in electrophilic substitution is, so थोड़ा बड़ा कर लो. What happens in electrophilic substitution is कि पहले तो alkenes का, ठीक है? Let's do a comparison, a small comparison with alkenes. So a comparison with electrophilic addition. As a comparison with electrophilic addition in alkenes. Okay, alkenes, what would happen was that the charge density in the double bond was the double bond had a lot of concentrated electrons. So there was a p orbital, there was a pi electron cloud, and the middle part. So the middle part had a lot of electrons over here with very high charge density. So if a bromine molecule would approach it, if a bromine molecule would approach it, it's going to become polarized. The bromine's electrons are going to get repelled. The bromine would become positively charged. One of the top bromines would get positively charged, and the bottom one would get a negative charge. And the positive bromine would then attract electrons from the pi electron cloud. And the polarizing power of this pi electron cloud is so much that that the Br negative gets completely repelled and it breaks off. Okay, so the polarizing power is very strong. So this is the next step of the reaction that so the next step of the reaction is your alkene with its pi electron cloud. Okay, there's a pi electron cloud. The Br positive and Br minus 1 ions are formed. Okay, because the negative ion has repelled and has broken away. The double bond over here is going to be attracted to the bromine over here, and it's going to be pulled by the positive bromine. So the positive bromine is going to attract it, and the positive charge would go away because it has gotten its electrons. But this carbon ends up losing electrons to bromine, so it gets a positive charge and a carbocation is formed. And in the next step, this Br minus 1 would come in and it would go and bond with the carbocation. Okay, so this was the mechanism of the reaction. And then obviously your product would be formed. Okay, Sara, is this clear?
Yes, sir.
Achha, but in the case of benzene, in the case of benzene, what's the same mechanism is not going to be followed, although the structures are very similar. In the case of benzene, you have 6 carbon atoms arranged in a cyclic manner. So 1 second, 6 carbon atoms. That's 1, 2, 3. And 6. Okay, so they are. So there are 6 carbon atoms with a hydrogen on each carbon atom. And the other thing is, so a hydrogen on each carbon atom. And the other thing is there's a pi electron cloud. So each carbon atom has this delocalized pi electron cloud, which is formed by the 4th electron. Okay, so they're all overlapping with each other. ठीक है, तो ये मैंने रफ में शो कर दिए. They're all overlapping with each other. And the ends are all hydrogen atoms. ठीक है, these are all तो यहाँ पे end पे they're all hydrogen atoms. I said, now what would happen is if a bromine molecule approaches it, the bromine molecule is going to be polarized. I said, bromine molecule is going to be polarized. So why would it be polarized? Because the electrons in this pi electron cloud are going to repel it. And there's going to be a very small partial negative charge, a small positive charge developing on it. And the positive bromine would be attracted to the electrons from the pi electron cloud. Okay, exactly the same way as alkene was doing it. Lekin in this case, the polarizing power of this pi electron cloud is not very large. Okay, so the repulsion is not very large, which results in a very small partial negative and a very small partial positive charge. And the molecule is not polarized. The molecule is not polarized sufficiently. So the positive bromine is not strong enough to attract the electrons from the pi electron cloud. जैसा यहाँ पे the polarizing power of this pi electron cloud was very large, which is why this molecule not only got polarized, but the Br minus one broke away, and this Br became a positive ion and then got attracted to the electron cloud. Here, nothing is happening. Nothing much is happening to the molecule. So there's not enough attraction. So you want to polarize this molecule more. You want the negative part of the molecule to be more negative. You want to push these electrons further to the right. Okay, you want to break this bond. You want this to become Br minus one, and you want this to become Br positive one. So for that to happen, a catalyst is added, and the catalyst is FeBr3 is one of the catalysts that's used. So FeBr3 is added. Iron has transition metals have a lot of protons, and transition metals are therefore very good catalyst. We studied this in transition metals that when you have a transition metal, so compared to normal metals, why are transition metals good catalysts? Because normal metals they usually tend to just lose electrons, like group one and two. They don't have a lot of protons. They don't attract the electrons very strongly, so they are mostly losing electrons. But when you move to the right of the periodic table and you move towards transition metals, मतलब group 1, 2, and then transition metals have a lot more protons. So because they have more protons in the nucleus, so they instead of losing electrons, they actually develop a weak attraction for electrons. For example, most transition metals are very unreactive because they don't like to lose electrons. They have so many protons that they instead actually attract the electrons very strongly. Gold is very unreactive, it never loses electrons. So weakly, so they have this very weak attraction for electrons. They weakly attract electrons. They're not non-metals. Non-metals strongly attract electrons. Transition metals are somewhere, I mean, that's the word, that is the reason why the word transition is used in the first place. Okay, you're transitioning from a metal to a non-metal. So non-metals strongly attract electrons. Transition metals, they just have this weak attraction for electrons. So to polarize this molecule further, iron from the other side starts pulling on the electrons. Okay, so the bond becomes even more polarized. The pi electron cloud over here is pushing this electron to the right, and there's a iron catalyst, and that iron catalyst is pulling the electron from the other side. And in this way, the polarization of bromine becomes bigger and bigger. I mean, this bromine becomes more positive, this bromine becomes more negative. Okay? Sara Burera, is this clear?
Yes, sir.
Yes, sir.
So then you have then you have the next thing. Okay, the polarization happens. Sorry. इसको मैं सेट कर लूँ. अच्छा, so the polarization happens और उसके बाद क्या होता है? उसके बाद ये होता है कि ये मुझे फिर से ड्रॉ करना पड़ेगा. 1 सेकेंड. पता नहीं ये क्या. अच्छा, so let's quickly draw the benzene molecule again. अच्छा, this one. Plus the p orbitals. So now let's assume that bromine has polarized and bromine is now strongly polar, bulk it's so polar that the bond has already broken and there is Br minus one. Okay, Br minus one and Br positive ion have formed. Now what would happen is the next thing that would happen is okay, the Br minus one would go and get attracted to FeBr3, and with FeBr3 it's going to form a dative bond. Okay, it forms a dative bond and the entire molecule would become an ion. It would get a negative charge. So there's a negative charge on the entire ion. And this Br positive ion now gets attracted to the electron cloud. And what it would do is okay, this is a फालतू का orbital था, this orbital over here, this one electron over here, which was involved in overlapping and it was forming a pi electron cloud. This electron is going to get attracted to Br positive one. And in that way, another bond carbon would be able to form a fourth bond. Okay. I mean, there was an H over here. Okay, all of these are hydrogen atoms. But now the pi electron cloud is going to be present on all of the carbon atoms. They would be overlapping except for the one that is attached to bromine. Okay, because its electron has gotten used up. It got attracted by Br positive. Br would no longer be positive. And instead, because the pi electron cloud has lost an electron, so the entire ring would be positively charged. Because who took the electron away? I mean, previously there was a p orbital over here, and they were all contributing electrons to this pi electron cloud. But the pi electron cloud would now become electron deficient because bromine would take that electron away. Okay, is this clear, Sarah? Abu Rara, is this clear?
Yes.
Yes, sir.
And finally, the next step is that um, the benzene pi electron cloud is now unstable because it needs an electron. It has positive charge. Okay, so it's going to try and pull because there's one electron missing in the electron cloud. Okay, which was taken up by bromine. Now, hydrogen has this tendency to actually lose electrons. Hydrogen always forms positive ions. So the last step would involve that this hydrogen would give its electron back, and it would leave the benzene ring. I mean, it would give the electron back, and in that way, the p orbital would be reformed. The H would lose electrons to the benzene ring. The delocalized electrons over here would become complete again, and H would be the one that would be doing that. So the final step is that H loses the electron to the electron cloud, and benzene's electron cloud is then complete. Okay, that's the final step. So at the end of the day, you would have you would have a complete benzene ring. Just on one side, there's bromine attached. Okay, the H has gotten substituted. Uh, Pele, all of them were hydrogens, but now one of them is bromine. Acha, what would the H do? The H would go and bond with the bromine that was lost earlier, and it would form HBr, and FeBr3 catalyst would be reformed. Okay, for further reaction. So that would be reformed. So I'm just going to go over this once more. Okay, you have a pi electron cloud. It polarizes the bromine molecule, but the bromine molecule is not sufficiently polarized because of the repulsion from the pi electron cloud. So you need a catalyst from the other side, an iron catalyst that pulls the electron from the other side. And in that way, Br minus 1 breaks off, bonds with FeBr3, ends up forming a dative bond. And the Br positive that's lost takes one electron from the pi electron cloud and bonds with it. And then the pi electron cloud is electron deficient. It needs its electron back, so it pulls an electron away from hydrogen. And in that way, H plus 1 is released, which ends up bonding with the Br minus 1 that was lost earlier to form HBr. ठीक है ये सारों को clear है? Sara, is this clear? Abu Huraira, is this clear?
Yes, sir.
Yes, sir.
अच्छा बाकी है कि
सर ये एंड पे क्या
क्या चीज
FE
FeBr3
हेलो
FeBr3
ये अच्छा ये प्रोडक्ट है एंड की
हाँ
अच्छा
ठीक है मतलब एंड में प्रोडक्ट है ना कि वो बेंजीन जो है ना उसके एच की जगह वो बस एक एच सब्स्टिट्यूट हो गया उसकी जगह बीआर आ गया और वो जो एच टूट के अलग हुआ है वो फिर वो जो बीआर पहले टूट के अलग नहीं हुआ था जिसके साथ जुड़ गया था इट हैज कंबाइंड विद इट और वो एचबीआर बना दिया और फिर FeBr3 दोबारा से फॉर्म हो गया ठीक है क्लियर है
यस सर
तो बस उसका वो लिख लेते हैं कि व्हाट आर द रिएक्शन कंडीशंस फॉर दिस कि सिंपली इसको ना वो सम अप कर देते हैं कि जी कैम्ब्रिज क्या एक्सपेक्ट करता है ये तो डिटेल वो अंडरस्टैंडिंग के लिए था एक तो ये बड़ा मसला है ड्राइंग बेंजीन इज काइंड ऑफ हमेशा अच्छा so this is benzene reacts with bromine you need a catalyst that's the difference compared to alkenes अच्छा catalyst कौन सा होगा it's going to be FeBr3 or it could be AlBr3 plus the same reaction could actually happen with the chlorine as well chlorine के case में it's going to be FeCl3 or AlCl3 these are your catalyst and what are the products of the reaction the products of the reaction are the benzene ring one of the hydrogens will get substituted by bromine and plus HBr molecule would be produced okay that's the product of the so that's the product of the reaction clear is this clear to everyone
यस सर
okay
Yes, sir.
then the next thing is that अच्छा इसका mechanism CIE what does CIE expect ठीक है the same thing that we just did earlier ठीक है the same mechanism I'm going to write that mechanism down अच्छा just the mechanism okay CIE would expect you to write this as you'll have a bromine molecule the benzene pi electron cloud is going to get it's going to repel the bromine one of the bromine would become positively charged the other one would become negatively charged there's going to be an FeBr3 on the other side that would be so that's going to be attracting electrons, वो वहां से electrons attract कर रहा होगा. So that's step number one. Then step number two of the mechanism. ठीक है, it's going to be frequently asked. Almost every paper has this mechanism. The next step is that. So the next step is okay. The benzene ring. The bromine would come and bond with the benzene ring, and the pi electron cloud would be electron deficient. ठीक है, so this is the part where this is happening जो हमने पहले किया था कि the pi electron cloud is not complete. ठीक है, it's missing over there because the p orbital has bonded with bromine instead of the benzene ring, and FeBr4 minus 1 is formed. ठीक है, where one of them is a dative bond and this entire thing is going to have a minus 1. It's going to have a minus 1 charge. अब फिर अगला step, the H would give away its electron so that the pi electron cloud becomes complete again. So the final thing is that your benzene molecule would and the benzene pi electron cloud would be reformed. Uh, but instead of one H, there would be bromine over there. As this is formed, and the H would go to form HBr, and simultaneously you will have an FeBr3 molecule that would be present. Okay, so this is the mechanism that you have to write in your exam. Clear है सारों को? इसको हम और थोड़ा सा highlight कर लेते हैं. ठीक है? Is this clear?
Yes, sir.
Yes, sir.
So now this was bromination and chlorination of benzene. There's another reaction that is called electrophilic substitution, and that is nitration of benzene. So right now we're only discussing electrophilic substitution, and we're talking about different types of electrophilic substitution. So just second, that is called nitration, and nitration is very similar. अब मैं इतनी detail के अंदर I'm not going to draw the mechanism. I'm not going to explain the mechanism. The mechanism would be exactly the same. ठीक है, there won't be any much of a difference. So this is known as nitration of benzene. Now what happens? Now what happens in nitration of benzene is कि पहले तो quickly ये benzene है और इसकी जो conditions होगी that would be कि you would have a reaction जिसके अंदर the conditions for the reaction are कि you would use concentrated sulfuric acid and you're going to use concentrated nitric acid, and the temperature would be 55 degrees centigrade or between 50 and 60 or close to 55, or one of the hydrogens around benzene. So one of the hydrogens around benzene would be substituted by NO2. So NO2 के साथ वो substitute हो जाएगा, and that's pretty much it. Bromination में भी यही था. Overall, what's happening? One of the hydrogen is getting substituted by bromine. Achha, but in this case, the mechanism of this reaction, you can be asked about the mechanism of this reaction, or whether you see a mechanism. The first thing about this is the सबसे number one चीज है. That is कि सबसे पहले ना nitric acid and sulfuric acid they react together. They react together to produce NO2 plus, HSO4 minus 1, and H3O plus 1. ठीक है, these three things are produced, two molecules of H2SO4. इसको check भी कर लो, it's a balanced equation. There are 5 hydrogens on the left side, there are 5 hydrogens on the right side. ठीक है, this is a perfectly balanced equation. अच्छा, so the first thing is कि your concentrated nitric acid, you must remember this equation because it's part of the mechanism. And that leads to the formation of this NO2 plus electrophile. So electrophile is created in the first reaction that happens, which is why you're adding concentrated sulfuric acid and concentrated nitric acid. So the first part is an electrophile is created. It's a positive ion. Positive ions, they get attracted to benzene. अच्छा, अगले स्टेप में फिर रिएक्शन स्टार्ट होता है. What happens is कि and it's the same exact it's the same exact mechanism. Okay, what would happen is कि NO2 plus 1 is going to come and it would be attracting the electrons. It would be attracting the electrons from the benzene pi electron cloud. और उन electrons को वो attract करेगा और उसके साथ फिर वो मतलब one of the p orbitals वही काम करेगा जो bromine कर रहा था. मतलब from here onwards it's the same thing. Okay, Br positive would come and pull one of the electrons from the benzene pi electron cloud, और उसके बाद the next of the steps are exactly the same. So the same thing happens here. तो benzene का जो pi electron cloud है, that becomes partial now. It's present on 5 of the carbon atoms, but on the 6th carbon atom, NO2 has taken away the electron. जिसके साथ H was already there, ठीक है, but the electron cloud, but the electron cloud is now with the NO2, and in the next step, there's an HSO4 minus 1 ion. So the benzene needs its electron back, so the electron is given back to the benzene pi electron cloud, and H instead, the positive H goes and it bonds with the HSO4 minus 1 ion that was produced in the first step. So the next part is the substitution is complete. The benzene electron cloud is now complete. Okay, that is now complete. NO2 has taken hydrogen's place, it has substituted it, and an H2SO4 molecule is now formed back again. So H2SO4 is kind of acting as a catalyst in this reaction. Okay, वो start में डाला था to produce the electrophile, and once the electrophile does its job, the H that the electrophile substitutes, that goes back to HSO4 minus 1 to form H2SO4 back again. So that's the entire reaction mechanism, and this is what you have to draw. Both of them are exactly the same, ठीक है? जिससे पहले हमने bromine का किया था, that was kind of similar, pretty much the same, and this other one is also kind of the same. ठीक है? They both have the same mechanism. It's called electrophilic substitution. You just need to know the conditions for this reaction. Okay, for nitration, you need concentrated sulfuric acid, and nitric acid, and the temperature has to be 55. जबकि वो substitution के लिए, what were the conditions? इधर नीचे लिखी थी. For substitutions, the condition are, और इसको highlight कर दें. So these are the conditions for substitution. That you need a catalyst, FeBr3 or AlBr3 as a catalyst. ठीक है? Clear है सारों को? अबुरेरा clear है? Sara, is this clear?
Yes, sir.
Yes, sir.
चलो ठीक है, ये फर्स्ट पार्ट है इलेक्ट्रोफिलिक सब्स्टिट्यूशन, और अब ये कि इससे आगे ना we'll only be studying electrophilic substitution.
सर ये बोर्ड का लिंक भेज देना.
मैं भेज रहा हूँ. अच्छा, इसके बाद अब हमने पढ़ा है कि we just started with benzene. Now benzene has a lot of derivative compounds. ठीक है, lots of compounds. Different groups can be attached to benzene. That would lead to different homologacies and different family of compounds. ठीक है, you have phenols, you have uh, alkyl benzenes known as arenes. So बहुत सारे different है. All of them are going to pretty much undergo electrophilic substitution. तो electrophilic substitution की ना variations पढ़नी है. ठीक है, just make sure you revise this properly. The mechanism wouldn't really be much of a lot different because all the other compounds are all benzene derivatives. Lekin we'll talk about the variation that's going to happen in the mechanism and in the speed of the reaction, uh, and how the bromine or at what positions the bromine is going to get attached or at what positions the NO2 would get attached. तो इसी की ना अब हम आगे variations पढ़ेंगे. ठीक है, तो ठीक है, next class पे फिर हम continue करते हैं. ठीक है, any questions? सारा clear है everything? अब उन्हें
Yes, sir.
चलो ठीक है,
ओके सर.
ओके, ठीक है, अल्लाह हाफिज़.
Love.